Okay, and we are live. I'm going to quickly go over the logarithms test, and we'll go over all 6 questions here, although you guys didn't have to do question 2 in the test, so this one here, but we'll go over it anyway. I tried to emphasize in the test here the difference between textbook questions and past paper questions, and then every now and then you get a worded question, which are more fun. But let's do question 1 then. So, given that log 3, so I'm going to write out the question here, log 3 of x plus 1 equals 1 plus 2 log 3x minus 1, show the following quadratic equation. Okay, well let's take this then, take it down, and let's use my rules. As per usual, I'll label my rules 1, 2, 3 and 4 in terms of the addition of logarithms, taking away of them, change of base rule and the power rule. So if we see a question like this and we've got logarithms of the same type, our first step here really is to get all our logarithms to one side. So let's take this one across, or you could take the other one across as well. So we get log 3 of x plus 1 minus 2 log 3 of x minus 1 equals 1. And so the only way that we can use our rule 1 here is if this here is inside our bracket. Can't have a number outside the bracket. So let's do that then. So we would have log 3 of x plus 1 minus log 3 of x minus 1 squared equals 1. Sorry, and now let's use my rule 1. So using rule 1 here now, the multiplication rule of logarithms, division rule, we get log 3 of x plus 1 over x minus 1 squared. And all of that is equal to 1. So now it's helpful just to think about your log 10 of 100 equals 2, because we can now simplify it. And so that's the whole purpose of doing what we've just done. So if we compare these parts here, and we know that 10 squared is 100, that would imply that 3 to the power of 1 equals x plus 1 over x minus 1 squared. And that's just a case of multiplying that out. X squared minus 2x minus plus 1. And so therefore 0 equals 3x squared minus 7x plus 2. And let's double check it's the same as what we got in the question. Yeah, exactly. Okay, hence or otherwise solve it. Hence or otherwise, hence. That's the key word here. Hence means you're basically going to use your part A. In fact, in most part B's, you use your part A. So let's use part A here. We've got our quadratic. So this here. And let's just factorize it. So we were talking about factorizing these in the lesson, but the easiest way really is to spot that in order to get our 3x here, we'll need 3 and 1, lots of x, because 3 times 1 is 3. There's another way that we can get to that 3. And in order to get to our 2 here, we will need 1 and 2. So either we have, as an option, 1 and 2, or we have 2 and 1. So let's think about it. 3 times 2 plus 1 times 1. That gets us to something that looks like 7. So let's use that first option then. So 1 and 2, both of them have to be negative, so that we get negative 7x. And so therefore we'll get solutions 3x equals 1, and that implies that x equals, let's put this below this one, implies that x equals a third, and the other one we're going to get here is x equals 2. whichever way around you want to put those. Let's do it the other way around actually. So we'd have 3x minus 1 equals 0. Let's do them properly. X minus 2 equals 0, so therefore x equals a third, or x equals 2. So we get two solutions here. And that's our question solved. So given that y equals 9 to the power of x, show that log 3 of y equals 2x. Okay. So question 2 now. Again, just make sure you sort of double underline your answers, or however you want to make them clear to the examiner. I guess in that case it's to show that, so you don't really need to do it for part A. But let's show what they were talking about. It was log 3 of something. So in order to get log 3 of something, I'll assume that I need 3's in here. So let's do 3 to the power of 2x, which is the same as 9 to the power of x. And then if I take log 3 of both sides, I'd get log 3 of y equals log 3 of 2 of x. Let's use my power rule, which is number 3. Therefore, we'd get log 3 of y equals 2x log 3 of 3. But we know that log 3 of 3 is 1, so therefore we get 2x. Part B. Hence deduce that log 3 of y equals log 9 of y squared. Log 3 of y equals log 9 of log squared. Okay, we're going to use both of our first definitions here to try and do that, I reckon. Let's give it a go. So we know that log 3 of y equals 2x. And we also know that x here, from our first definition here, let's put a sign like that here. We know that if y equals 9 to the power of x, that means that log 9 of y equals x. So therefore we get 2 log 9 of y. I think that's what they were asking for. Let's double check it. Okay, and then we just got to take the squared inside. So that's our side note there. And so therefore log 3 of y by rule 3. A lot of rule 3 here is log 9 of y squared. Okay, part C. Part C, use your answer to part B to solve the equation 2 minus 3x log 3 of 2 minus 3x. Okay. Well, let's assume that y is 2 minus 3x. And that's where we're going to start. Let me write out the question here so I can copy it down below. Minus 3x equals log 9 of 6x squared minus 19x plus 2. My first thoughts were maybe 6x squared minus 19x plus 2 is just 2 minus 3x squared, but it's not. So that means that we're going to use part B. So in part C here, we're going to use part B. Let's say that my y is 2 minus 3x, and then I'm going to use this rule here, basically. And I'm going to use it on the first part here, my left-hand side. So therefore log 3 of 2 minus 3x is the same as log 9 of 2 minus 3x squared. And so that means that we can say that this here is equal to our right-hand side there. And since we got log 9 of both sides, because they're both log 9s, we can cancel. And so all we're left with is the inside of the brackets here. So 2 minus 3x squared equals 6x squared minus 19x plus 2. So let's solve it. We'd get 4 minus 12x plus 9x squared is 6x squared minus 19x plus 2. Take it all to the left-hand side so that I get something equal to 0, so I can solve it. So therefore I get 3x squared plus 7x plus 2. Oh well, that's exactly the same as question 1. Use your answer to part B to solve that part of the equation. Fine. This is probably the 6 marks of the question, or 5 marks. Be the majority of it. And we've already solved this before. 3x, x, 2, 1, except both of these are positive now. And so therefore x is minus 1 and minus 2. And although we can't have a negative logarithm, so when we see these numbers for minus 1 and minus 2, our logarithm is log of y, and so therefore it doesn't matter. We could have minus 1 and 2. That means that y would be 9 to the power of minus 1 and 9 to the power of minus 2, which is the same as 1 over 9 and 1 over 81. So we can get solutions here. Okay, question 3. Let's see what it's asking on us. Question 3, write 3 ln 3, remember ln is log of e, ln 9, in the form of ln of a. Okay, well, we're going to use rules 3 and 1, I think, no, 2. Log rules 3 and 2. There we go. Let me just double check up here that I put the right rule down. I might not have done. No, that's using rule 2. There we go. I'll upload these onto your manage back after this, so you'll have a copy of them. Okay. So let's use rule. Okay, I'm going to use a separate line every time I use a rule. So I'm going to use rule 3 to start off with. So let's use rule 3. Therefore, we get ln of 3 cubed minus ln of 9. And now let's use rule 2, which would mean that we get ln of 3 cubed over 9. Well, 9 is 3 squared, therefore that is just ln of 3. And so we've shown that all of these are equal. We've done our proof in part A. Part B was show that this here, or find the value of x such that this here is equal to minus ln of x. Let's double check that. Yeah. So it's always worth mentioning if you use an earlier part of the question. So I'm going to say part A, and then I'm going to say implies, because it does. It implies that we've got ln 3 equal to minus ln of x. Well, now we have to use our rule 1, because we can't cancel with the negative in front. Not 1, rule 3, because we can't cancel with our minus in front of our x. So therefore we get ln 3 equals to ln of x to the minus 1. Now we can cancel our logarithms down. So all we're left with is 3 equals x to the minus 1. Well, x to the minus 1 is 1 over x. So therefore x is 1 over 3. Multiply 3 by x, divide by 3. Great. Question 4. Question 4, solve the simultaneous equations. So let me write them up. We've got 1 plus 2 log 5 of x equal to log 5 of 7y and log 7 of 6x minus 1 equal to 1 plus log 7 of y. Okay, well, let me copy those down. Classic simultaneous equations, get them into some shape or form so that you can cancel either x or y down. You can use substitution, always works as well. But the first thing we need to do is get rid of our logarithms if we want to solve these. So as per usual with simultaneous equations, I'm going to draw a line between every pair so that it's very clear which my pairs are. So first thing I'm going to do is I'm probably going to use rule 3 on the first one. And I'm going to take it all over to one side in terms of my logarithms. So I get 1 equals to, no, let's do it the other way. Let's get log 5 of 7y minus log 5 of x squared equal to 1. I've used rule 3 here on this one here, and that's how I've gotten to that there, in case you're not following. And then I'm just going to take the other one as well to one side, so I get log 7 of 6x minus 1 minus log 7 of y equal to 1. Well, we've got 1 on both sides. Sorry, we've got the same one on the equations. Okay, so now we're going to use our rule 2's to put these all as one logarithm so that we can simplify further. So we get log 5 of 7y divided by x squared equals 1, and log 7 of 6x minus 1 over y equals 1. And then using your log 10 of 100 equals 2, we know that 5 to the power of 1, which is just 5, would be equal to 7y over x squared, and 6x minus 1 over y is equal to 7. So now we're starting to get stuff that looks like simultaneous equations. So let's multiply these out, and let's get our x's and y's to the same side. We would get, or substitute one into the other. That might be neater in this case. But anyways, we've got 7y is equal to 5x squared, and we've got 6x minus 1 is equal to 7y. Well, let's take one away from the other. Might be clearer if I just switch these around, not doing anything there other than using the fact that it's an equal sign. So obviously we're going to get 0 on that side, and then we're going to get 5x squared minus 6x plus 1. Again, when we're solving these, think what goes into 5x. Well, at 5x squared, it can only be 5x and x, and therefore we need 1 and 1 to get to our 1 here. So we think about our 5x, and then we think about our 1 here, and therefore these must be 1s. And so now all we've got to think about is our signs to get the term in the middle. We need minus and minus. So therefore, x is 1 or 1 over 5. All that's left now is to find y. So y would be equal to, using the top equation up there, y is 5x squared over 7. So therefore, y is 5 over 7. Or y could be 1 over 5 squared over 7. And so therefore y would be 5 over 7. Or 1 over 5 squared is 1 over 25. So therefore we cancel out one of those 5s. Or 1 over 5 times 7, which is 35. Okay, question 5. Now question 5 was the hard one. we've got a plus b log 4 of 7 plus 60 log 8 of 14 equals 0. I've got to get this done quickly because I'm teaching period 2. So that gives me 14 minutes to do the last 2 questions, which is ambitious, but we'll manage. So, question 5. So the hint I gave you guys is that if you get these both as the same logarithm type, you can cancel down. In fact, there's loads of ways of doing this question. You could have done log 4, you could have done log 8, either one would have worked. The easiest, though, is to do log 2. And that's using our rule for change of bases. But the first thing we need to do before we can change our bases is get rid of these numbers in front. And we do that using our power rule, which is rule 3. So if we use rule 3, we'd get a plus log 4 of 7b plus log 8 of 14 to the 60 equals 0. Now let's use our change of bases, which is rule 4. And we're going to do it with log 2. I'm going to show you also how to do it with luns or with whatever you want to do it with. But let's do log 2 first. We're going to use, let me put that in some sort of a highlight. We're going to do it with log 2 to start off with. So using our change of basis rule, we get log 2 of 7b over log 2 of 4. And we get log 2 of 14 to the power of 60 over log 2 of 8 equals 0. I've just realized that you don't even need to do step 1. You can just skip step 1 and you can leave, for instance, your b and your 60 outside the brackets. Would make a difference. But log 2 of 4, well, that can be simplified down, and log 2 of 8 can as well. So really what we've got is b log 2 of 7 over log 2 of 2 squared, while log 2 of 2 squared would be 2 log 2 of 2, and then log 60 log 2 of 14 over 3 log 2 of 2, because 2 cubed is 8. So, well, log 2 of 2 is 1, log 2 of 2 is 1. So all we're left with now is a plus b over 2 log 2 of 7 plus 60 log 2, 60 over 3, which is 20, log 2 of 14 equals 0. I'm now going to use rule 1 to split up my 14, because I know that 14 is 2 times 4, 2 times plinking 7, a plus b over 2 log 2 of 7 plus 20 log 2 of 2 plus 20 log 2 of 7 equals 0. And then let's separate this out. Well, we've seen here there's another log 2 of 2, so we can cancel that out. All we're left with now is a plus 20 and b over 2 plus 20 on the outside of log 2 of 7. So we need this equal to 0, since it's like working with x and y's. Our log 2 of 7 is not a constant value. Well, it is a constant value, but it's got nothing to do with this here. They're different types of terms. And so the easiest way to solve this now is to realize that we need this here equal to 0 and this here equal to 0. And using that fact, we've got a equals to minus 20 and b over 2 equal to minus 20, and so therefore b is minus 40. I'm going to quickly show it to you in one other way. Let's use learn, because you can do learns with practically anything. Let's take this up here, duplicate it, and I'll show it to you with learns. So if instead we were going to use our change of bases, so rule 4 with ln, and we're going to use learns on this, let's try and see what we get. We would get a plus b ln 7 over ln 4, and we would get, see if it works, 60 ln 14 over ln of 8 equals 0. Well, let's get them all in terms of ln 2s and 7s. So we'd get a plus b ln 7 over 2 ln 2, same rules as last time, but this is using rule 3, power rule, and plus 60 ln 14 over 3 ln 2 equals 0. Well, we've got to multiply them by 6, all times by 6. So we've got to get them over 6 ln 2, so that we can put them under the same denominator. So 6 ln 2 on the bottom. You can go over this slower when you need to, or ask me if you need any help on this sort of stuff. But now we've got 6a ln 2 plus b ln, well, it's going to be 3, isn't it, using our fractions, 3b ln 7. Going to need even more space than that. And then 60, could have split that into 20. I might actually do that. Just saves me a little bit of time. 20. Therefore, I won't need to times by 3 here. Therefore, I won't need 6 on the bottom. I'd only need 2 ln 2. And then we'd still have to double this, so we'd get 40. Let's split it straight away. Ln 2 plus 40 ln 7. Okay, well now we've got ln 2s and 7s. Since we've got this on the bottom, we can actually cancel it, because we can multiply it through by 0. Well, multiply both sides by that, and 0 times that wouldn't change anything, but it would get rid of our fraction. And so now what have we got? We've got 2a plus 40, and that's in terms of ln 2. And then we've got b plus 40, and that's in terms of ln 7. Well, same process. We need this equal to 0. We need that equal to 0. So we'd get 2a plus 40 equals 0, so therefore a is minus 20. And b plus 40 equals 0, so therefore b is minus 40. So that's just showing you quickly how you can do another way for this. So let's call this alternative method. This gives me 6 minutes to do the last one. Alt, I can't even spell today. Alt meth. Question 5. This might be more difficult because I've got to scroll up and down. It's question 6 now, sorry. All living plants have an isotope called carbon-14. When that plant dies, blah, 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 blah. Okay, let's think about the key parts here. We've got the death is modeled by this function here, where they're positive constants, to present day t years after its death. So at t equals 0, we are a dead plant. At the time of death, a plant is defined to have 100 units of carbon. Okay, well that means that we need, let me do it up here actually, save some time. Part A here on question 6, we would have t equal to 0 at time of death, and so therefore A would be equal to A0 plus, well, A here we know is 100 at time of death. 100 would be equal to A0 e to the minus k lots of 0. Well, e to the power of 0 is just 1. Anything to the power of 0 is 1. And so therefore we just get a0 equal to 100. Part B. Show that, show that k equals ln 2 over 5730. Okay, carbon-14 is known to decay. Taking half, okay, the time taken for half the original amount to decay of carbon-14 is known to be 5730. So we know that it starts at 100, half will be 50, and we need our function to be equal to 50 for some value of k, with a value for t equal to 5730. Okay, now I am going to take this down to the bottom. Copy, delete, 4 minutes, delete, paste. Okay, so we have to solve this for k. Let's get rid of our 100 here so that we have something in the form of log 10 of 100 equals 2. So therefore we get k, I'm going to write it like this because I prefer writing it like that, where we've got the algebraic term on the right-hand side. Okay, now let's use our logarithms. Log 10 of 100 equals 2. Therefore, well, of course, log of e is ln, so we've got ln of a half equals to ln of, this power, 5730k. And they just want you to separate out k. Well, we know that ln of a half is the same as ln of 2 to the minus 1 equals minus 5730k. Therefore, we've got minus ln 2 equals minus 5730k. Well, obviously, we've got a minus on both sides here, so we can get rid of those. And so we'd get k is equal to ln 2 over 5730. Okay, part C. Find correct to the nearest 10 years the time taken for the plant's death. 25% after plants for 25% of the carbon-14 to decay. So we need 75, and because 100 is 100%, 25% less 75, and we need that equal to our function, so 100 e to the minus ln 2 of 5730t. And we need to solve that now for our value of t. So 3 over 4 equals e to the minus ln 2 over 5730t. Let's copy this down. Oh no, whoops. Copy it. Copy. Delete. To the nearest couple of significant figures. This is the only part here where you needed a calculator. And I kind of didn't foresee that. I thought the whole paper was non-calculator. But anyways, if we learn both sides, we'll separate out our t. We'll get ln of 3 over 4 equals to minus ln 2 over 5730. It's very much like our last step there. And so therefore t is going to be a great big mess, but I'll let your calculator sort that out for you. Minus 5730 over ln 2 ln of 3 over 4. Okay, I'm out of time, but just plug that into your calculators and you will get the answer, and make sure it's correct to 3 significant figures. Remember to double underline your answers.